Hello, welcome to my channel. Now the question here says, a stone of mass 500 gram is thrown upwards with a velocity of 40 meters per second. Calculate the kinetic energy of the stone. If it reaches a height of 60 meters, find the potential energy at this height and the energy lost. And we are given acceleration due to gravity as 10 meters per second square. Now, I'd like to start by mentioning or stating the parameters that were given or the quantities that were given in the question. Now, first of all, we are given the mass of the stone, and that is M is equal to, the mass is in gram, but it is not the SI unit in physics. The SI unit of mass is in kilogram. So we have to convert that gram, which is 500, to kilogram. In order to convert gram to kilogram, you simply divide by 1000. So when we divide this by 1000, it's going to give us the mass as 0.5 kilogram. And then moving further, the next parameter we are given in the question is the velocity. So I'll call that V is equal to 40 meters per second. That's the velocity that we're given in the question. Then after that, the next thing we are given is the height. So I'll call that H is equal to 60 meters. So the height is 60 meters. And then lastly, at the end of the question, we are given the acceleration due to gravity, which is 10 meters per second. So I'll call that G is equal to 10 meters per second square. Now, according to the question, we have about 3 quantities to calculate here. The first part of the question says we should calculate the kinetic energy. So I'll call it K dot E. So kinetic energy, we have to calculate that. After that, we're asked to calculate the potential energy at the height. So potential energy, I'll call it P dot E. Potential energy, we're also looking for that. And then finally, we're asked to find the energy lost. The energy lost. So let me call it E lost. And that is question mark as well. Now let's take them one after the other. The first question is to find the kinetic energy. And I want to believe that we already know the kinetic energy formula. That kinetic energy is half multiplied by the mass multiplied by the square of the velocity. So the formula for kinetic energy is half mv squared. Half mv squared. So let's substitute values now. So I'm going to say the half, which is 1 over 2, multiplied by the mass, which is 0.5, 0.5, and then multiply by the velocity, which is 40. But don't forget, it is velocity square. So I'm going to write 40 square as the velocity. Is that okay? So now, we are going to simplify this further. I'll write this as 0.5 multiplied by 40 square, which is 1600. That is 1600. All divided by 2. And then that will simplify to give us the kinetic energy as 400 joules. Don't forget, the unit of energy is joules. So the kinetic energy is 400 joules. When you multiply 0.5 by 1600 and you divide by 2, it's going to give you 400 joules as the kinetic energy. So that is the first part of the question. Then we're also asked to find the potential energy at the height reached. So don't forget that the formula for potential energy, I want to believe we also know that. So I'll say therefore the potential energy is equal to the mass times the acceleration due to gravity multiplied by the height. This is the formula for potential energy. So let's substitute the values now. The mass we can say is 0.5. So I'm going to say 0.5 multiplied by acceleration to gravity, which is 10. The acceleration to gravity given to us is 10 meter per second square. Some problem can state it as 9.8, which is the accurate value, but we are taking an approximate value of 10 meter per second squared. So multiply by 10 and then multiply by the height. The height is 60 meter, and that is 60. So if we multiply all this together, we are going to get the potential energy. This multiplied by this is going to give us 5. Multiplied by 60 will give us 300 joules. So the potential energy obtained or attained at that highest level of 60 meters above the ground is 300 joules. Now, finally, we are asked to calculate the energy lost, which I'm representing with E lost here, the energy lost. So the energy lost in the process, that is what I call E lost, is equal to the kinetic energy, which is 400. Don't forget the kinetic energy is higher than the potential. So the kinetic energy, which is 400, minus the potential energy at that height, which is 300. So that tells us that in the process of converting the kinetic energy to potential energy at that height, the energy that was lost in the process is 400 minus 300, which is 100 joules. And that is the energy lost. Hope you enjoyed this video. Please don't forget to like, subscribe, and share this video so that others can learn from it. Please, thank you, and I'll see you in my next video.